Hello guys, my name is Desmond and I welcome you to my YouTube channel. So guys, for today's lesson, we'll be looking at physics paper 1, question 8 exam paper of November 2017. So today's lesson is suitable for learners in grade 10, 11 and 12. And again, if you are upgrading, this lesson is also suitable for you. So guys, before we start with the business of the day, I just want to take this opportunity to indicate to everyone that we've got our Telegram channel. This is where I post all the question papers for grade, let's say actually for high school. Not necessarily for the subjects that I do, but for almost all the subjects that you can think of in in high school. So I would encourage you, if you've got a Telegram account, to just search Solve Your Exam Papers. This is where you'll be able to access all of these question papers. So guys, without any waste of time, let's now start with our question for today. I'm not really sure if you are able to see on the screen, because I've just noticed on some videos it's a bit blurry. I'm not really sure if it depends on the device that you're using, but otherwise I've just written down the statement there. I'm going to quickly read it out, and again, if you're able to see on the screen, then it's also good. But just to accommodate everyone, I'll just make sure that for every question I bring the screen and I read the question, so that in case if you're one of those who are not able to see, you can just write down the question as I read it out. So guys, question 8, you're advised to start this question on a new page. Okay, so guys, it's very much important that you start each question on a new page. So we are given a statement there, and it reads as follows: A and B are two small spheres separated by a distance of 0.7 meters. Sphere A carries a charge of positive 1.5 by 10 to the exponent negative 6 coulombs, and sphere B carries a charge of negative 2.0 by 10 to the exponent negative 6 coulombs. So guys, the statement that I've just read, it's represented by the diagram below, or the diagram drawn below that statement. So it's very much important that you are able to read the statement at the same time picture how the diagram should look like, just in case if it happens that you're given a statement and you're not given the diagram. So as you can see below the diagram, there's also a statement which says P is a point between A and B, and it's 0.40 meters from sphere A, as shown in the diagram above. Okay, so guys, these are one of those questions where you should make sure that you score maximum marks, because in most of the previous question papers, you will never find a question paper without this question. So that's why for today's lesson, I had to make sure that we also cover this lesson, because this is where you are most likely to score easy marks. So we're going to do this question from 8.1 up until the last question. So in case if you're watching this video from one of my platforms, just be aware that I do online live lessons on my YouTube channel where I solve questions from the start until the end. But on other social platforms, you might find that it's only question 1 or 8.1 which is posted, and the following day I post other questions for this same question. So if you want to watch a full lesson, just go to my YouTube channel. Under playlist, there should be a playlist named live online lessons or something like that. But guys, let's now get started with business of the day. So guys, I just want you to be aware of something. I'm going to redraw that diagram which is drawn there, by referring to that statement. Remember, they said A and B are two small spheres separated by a distance of 0.7 meters. Okay, so you'd have A and B. I'm just drawing this so that you've got an idea of how to interpret the given statement, and again how it follows in terms of drawing that diagram, because that diagram, there are steps in which were followed to draw that diagram. Okay, so now remember, we've got A and B which is separated by a distance of 0.70 meters. Okay, and the statement carries on to say sphere A carries a charge of a positive 1.5 coulombs. So we've got a positive charge which is 1.5 by 10 to the power negative 6 coulombs, and sphere B carries a charge of negative. So for sphere B, we know it's a negative charge of 2.0 by 10 to the exponent negative 6 coulombs. Okay, so now we've got that statement which says P is a point between spheres A and B and is 0.4 meters from sphere A, which is very, very much important, guys. That point P, okay, that point P, let me just do this and say that point P, okay, it's what matters the most in this case, guys. You need to be aware that P is a point between, okay. This statement is very, very much important because that point can be placed on this side of charge B or on this side of charge A, but in this case they specified that is between A and B. And again, in some instances they might not indicate exactly where it is, where they request you to tell them exactly where it is by means of calculations. But let's just hope in the future we'll come across a similar question. But for now, they said point P is between A and B. And again, most importantly, guys, they just indicated that it's 0.40 meters away from sphere A. Okay, so what does it mean? It means it now remains our responsibility to know the distance from there to there. Okay, so obviously, because we know that the total distance between A and B is 0.7 and sphere P is placed 0.4 meters away from sphere A, so that means that distance from that P to sphere B, it should be 0.30 meters. Okay, so this is what I wanted you guys to notice before we start with the first question, because you might find that as we continue we might need that information. Okay, so guys, just note that information down if you're writing. But as I always say, I would encourage you guys to just pay attention to what I do, because I'm going to make sure that I post this lesson online so that you are able to catch up at a later stage. It's also beneficial to those who are not able to join this live lesson. They can just at a later stage watch this lesson. So now let's start with question 8.1. So guys, I've just indicated that if you're not able to see, you can just listen as I read the question. So this question is not that long, it's not that much complicated. They say define the term electric field at a point. Okay guys, they say define the term electric field at a point, and this question is allocated 2 marks. So guys, it's very much important that you take note of what they want you to define. They said electric field at a point. Okay, so I'm going to start my statement with electric. So this is the answer to the question, guys. Electric field at a point. I want you to take note of what I've started with, guys. That statement, very much important. Why? Because the question said electric field at a point. So that's why my statement starts with electric field at a point. Then I can continue with the definition. So obviously the definition, guys, is there in your textbook. Surely your teacher have given you the definition of electric field at a point. Depending on the information that you've got, you can just make use of that information to provide as an answer to this question. But what matters the most is to be careful of what the question says. In this case, it says electric field at a point is, if you've got something to write, you can write. It doesn't really matter that much. So this is just a definition, so you can just write as I write. So is the force per unit positive charge placed at that point. Okay, so guys, this is how you answer the first question, where the question says define electric field at a point. By so doing, you score your 2 marks. Okay, so this is how you score your 2 marks. So now, guys, let's move to the next question. Okay, guys, so now let's move to question 8.2. So I'm just going to read the question as I did on the previous question. So the question says, calculate the magnitude of the net electric field at point P. And this question, it's allocated 4 marks. So guys, I'm not sure if you're able to see, but the question says calculate the magnitude. Remember, the word magnitude refers to the value. So calculate the value or calculate the size of the net electric field at point P. So guys, let's just check if we've got a formula sheet provided on this question paper. So we've got formula sheet. Now we need to make use of this formula sheet to choose the relevant formulas for this chapter. So guys, this is where you concentrate with regards to choosing the correct formula. So as you can see, we've got the formula for calculating force. This is the V, this is E, and then this is N, or the other way of calculating N is that one. So now we are not requested to calculate the force, not the voltage, not the number of electrons, but the electric field at point P. So now it's just a matter of us having to choose between these 2 formulas. Okay, so guys, it's very much important that when you're requested to calculate the magnitude of a certain unknown, you consult the formula sheet and check which formulas are available. From there, based on what you're given on the information, you'll be able to choose. Again, we've got the constants, guys. These are the physical constants. So you must at all times be aware that you've got physical constant, which you might find some values that you could need. So guys, let's see. In most cases, when it comes to this chapter, you might find that the constant that we normally use, let me see, I will tell you just now that K. Can you see Coulombs constant K, which is 9.0 by 10 to the exponent 9 Newton meter squared per Coulomb squared. So this is the constant that you normally use with regards to this chapter. And the other one is the charge on electron, which is negative 1.6 by 10 to the power negative 19 coulombs. So these are the two physics constant that we normally use in relation to this chapter. So guys, let's quickly go back to our question. I'll read the question for the last time and straight away start with the first question. So guys, they say calculate the magnitude of the net electric field at point P. Okay, so obviously this is the formula which is relevant to this question. Why this formula, guys? Remember, they're saying calculate the electric field at point P, and this is the formula that we have to calculate the electric field. Why specifically this formula? It's because I've just shown you that we've got constant which is given, we're given the charge from the statement, and we also have the distance. But because point P is experiencing a electric field strength as a result of A and B. Remember, it's between A and B. So that means we'll have to then use A and B to calculate the strength at P. Okay? So now what we calculate is now the net, which is equals to E of A plus E of B. Remember, guys, very much important again to note on this question. Let me show you something. Calculate the magnitude of the net electric field. I just want you to note that the net electric field at point P. So the word net, it means total. Okay, so this formula, it's not for calculating the net, it's not for calculating the total, but in most cases you are given a mark for that formula, which shows that you know exactly what the question wants you to calculate. So with you adding these two, it shows that you fully understand that point P is between A and B. It is therefore important that when you calculate the electric field strength at that point, you take into consideration the fact that it's between A and B. Okay, so you can just expand this formula to say this is K and then this is charge at A. Obviously this will be R squared at A, obviously from A in relation to P, plus K Q at B divided by R squared. Okay, so now guys, straight away we just substitute and punch on a calculator and see what we get when we punch on a calculator. I'm not sure where's my calculator, but I hope you've got a calculator, so I'll just guide you in terms of how to do it. So now we substitute. What is K? We've just noticed from the physics constant, the value of K, I remember it's 9 by 10 to the exponent 9. Okay, so what is the charge of A? It's there, it's 1.5 by 10 to the power minus 6. Okay, all over, what is the distance from point A to point B? It's 0.4. Okay, so it's 0.4 plus, you do the same, K, it's 9 by 10 to the exponent 9. And then what is the charge of B? It's negative 2.0 by 10 to the negative 6 all over. What is the distance from B to P, or from P to B? So do you now notice that it was very much important that at first we analyze that statement or that given diagram and fill in all the missing information? So in that case, we're given a distance from A to point P. We had to calculate the distance from P to a charge B, or sphere B, and the distance is 0.3 squared. Why 0.3? Because when you add these two, they have to take you back to that given total distance. Okay, so guys, if you've got a calculator, you just need to punch all of this and see what answer you get. Okay, so let me just quickly check my calculator, and then I will tell you how to punch that on a calculator. Okay, there you go. So let's start, guys. You just do a fraction button, you open bracket, 9 times 10 to the exponent 9, and then you close the bracket, open 1.5 times 10 to the exponent negative 6, you close, and then you go to the denominator side, it's 0.4, you close, you squared, you go to the side, you add. Now we are doing this part. Follow the same procedure. Start with the fraction button, you open 9 times 10 to the exponent 9, you close, you open, it's 2 by 10 to the exponent negative 6, you close, you go to the denominator side, you open 0.3, you close, and then you squared. Okay, so the answer that we get is 284,375. Okay, let me see, it's 284,375. I'm not sure if you also got the same answer, guys, but if you punch all of that correctly, you should be able to get that answer. Okay, so now there's a way in which you can write this answer in scientific notation. So remember, the unit for this is Newton per Coulomb. Okay, you can write it as Newton.Coulomb to the power minus 1, or as Newton per Coulomb. It's one and the same thing. So guys, I think for today's lesson you will be able to learn how to write a number in scientific notation. So this is how I used to do it. From my lower grades, I would just count, let's just count from this number up to that point there. So let's see, we've got 1, 2, 3, 4, 5. Okay, so that means this is the same as 2.84 if I round it to 2 decimal places by 10 to the exponent 5 Newton per Coulomb. Okay, so this is how you convert a number and write it in a scientific notation, and at the same time you round it to 2 decimal places. So the reason why I had to stop there is because I wanted to say 2 comma this number. Otherwise, if I stopped there, it was going to be a addition of 5, then 6, then it means it was going to be 0.28 times 10 to the power 6 Newton per Coulomb. Okay, but otherwise you should just write it up to that point. So now guys, this is how you score how many marks. Let me just check on the question paper. This question, it was allocated 4 marks. So I'm just quickly going to show you exactly where you score your marks. So guys, what I like about physical sciences is that for just copying the formula from the formula sheet, they give you a mark. So they are going to give you a mark for just writing that formula, and again they will surely give you a mark for correct substitution. So you substituted twice, they're going to give you 2 marks. I hope you can see exactly where you score your last mark. This is where you get your last mark. Guys, very, very much important. An answer with the correct SI unit is what makes you to obtain maximum marks. I'm not really sure of what they do if you don't write the unit, but if you don't, then it means this is not a complete answer. That number could mean anything else. It could mean liters, it could mean volume, area. For as long as you don't specify the unit, then just know you stand a very good chance of losing some marks. So guys, for now, you can just have a glass of water and get ready for question 8.3. So ladies and gentlemen, if you have watched this video this far, it's a good indication to me that you're actually enjoying this lesson, you're getting value in this lesson. So please do make sure to just join our community. If you're new, just hit the subscribe button, just like the video, and also share with friends. Otherwise, if you've got any questions, guys, please do feel free to just post your questions. It could be suggestions, comments, or whatever it is. You can just post on the comment section. So guys, let's quickly solve this question. Now we move to question 8.3, and the question reads as follows: a point charge of magnitude 3 by 10 to the exponent negative 9 coulombs. It's now placed at point P. The question says calculate the magnitude of the electrostatic force experienced by this charge. So this question is allocated 3 marks. Remember guys, this question paper, it's for grade 12 and it's posted on my Telegram channel. You can just quickly join the channel and access this question paper. That's when you'll be able to clearly see these questions. So this is one of those easy questions where we won't have to stress that much. We won't have to waste a lot of time. Guys, I've shown you the formula sheet with all the question papers that you need. There's a question paper. There's a formula which says force is equals to charge multiplied by electric field. So this is the formula that we're going to use to calculate the magnitude of the electrostatic force experienced by this charge. So remember guys, they said a point charge of magnitude 3 is now placed at point P. So it's 3 by 10 to the exponent negative 9 coulombs. Okay, so now guys, it's just a matter of substituting. This is not a difficult question. You just substitute and calculate the magnitude of the electrostatic force experienced by this charge. A charge of this magnitude 3 by 10 to the exponent negative 9. You obviously calculated this from the previous question. The answer, I think it was 2.84. I remember I counted up to 5. Okay, so guys, you just easily punch this on a calculator. Let's see. Open bracket 3 by 10 to the exponent negative 9. You close, you open 2.84 times 10 to the exponent 5. And then you get this as your answer. I'm not sure if you're getting the same decimal. It's 0.0000852. Okay, so remember, this is the force. So it's calculated in newtons. So now I'm glad, even on this question, I'm going to show you how to write that number in scientific notation. You just do exactly the same thing, guys. The only difference in this case is that you are counting in that direction, whereas on the previous question we counted in that direction. So that means when you count in that direction, your exponent is times 10 to a positive number, but in that direction is times 10 to the exponent negative number. So let's see, this is the number that you write as negative, so it will be 1 2 3 4 5, okay, up to 6. But in this case, guys, you stop at that point. You just stop after the first number, okay? This is where you stop. Just like when we stopped, when we're counting from from right to left, we stopped at the last, the second last number. So, guys, that means the answer to this question in scientific notation, it's going to be 1 2 3 4. Then it's going to be 8.52 by 10 to the exponent. Can you see? This is where you now write it as negative. How many times did you count? 1 2 3 4. So that means it's negative 4 because it's a force, then it's in newtons. Guys, I'm not sure if I made it complicated, but please do let me know if I didn't make it easy, so that I can somehow do a special lesson teaching you on how to write a number in scientific notation. Okay, so guys, now this is where you score your marks. We've just noticed that in physics, they just give you a mark for copying the formula, guys. That's one thing for sure. They give you a mark for correct substitution into the correct formula. And the final answer is also given a mark. Okay? So guys, that's how you solve this question. But before I close today's live lesson, let me just indicate to you guys, if you've got 8 9 1 0 2 7, let's say you calculated your answer and this was your final answer, it could be Newton per coulomb, it could be what else, it could be, let's say, a force, just like that. It could be a charge in coulombs. It doesn't matter what the what is it, what do I want to say, guys? I mean the unit. I'm just thinking of this number. I wanted to say it doesn't matter whatever the unit is that you'll be calculating. I just want to show you how to write this in scientific notation. So it's going to be 1 2 3 4 5. This is where you stop, right? Then it's going to be 8.91. This is how you round it to 2 decimal places, obviously. Then it's by 10 to the exponent 5. So that's why I was saying when you are counting from right to left, it's by 10 to the exponent positive number, which is positive 5. Okay, so if you had, let's say, 0.00000127 okay, so this is how you then do this one. You just count up until the first number. You've got 1 2 3 4 5 6. Okay, this is where you stop. Then it's going to be 1, 2. Obviously it's 7. You can't round it to be 8. Then it's 7. Then it's times 10 to the exponent negative number, because you're counting from left to right. How many times? 1 2 3 4 5 6. Then it becomes negative 6. Then the unit, whatever unit it is, then you give it that particular unit. It obviously will be dependent on the question that you'll be solving. So guys, I assume you enjoyed today's lesson. So As for me, I can't wait for tomorrow's live lesson. Remember, guys, I'll be doing these live lessons until you're done with your final exams. As soon as you're done with all your exams, then I won't be doing live lessons, but I'll just be posting some videos in preparation for grade 10s and grade 11s, so that we start afresh with some new videos, a different approach. I think it's going to be interesting. And again, I'm planning to have an online winter classes. In case if you think it's a good idea, you can just indicate in the comment section. And again, make sure to drop me WhatsApp text so that you've got all the information in relation to our future plans. So guys, thanks very much for joining. My name is Desmond and I'm out.